Use the derivative formula. F prime of a equals limit as h goes to 0 of f of a plus h minus f of a divided by h to find the derivative of f of x equals the square root of x squared minus 3x, where a equals to negative 1. First thing to do is to set up the derivative formula for a equals negative 1. So that will be f prime of negative 1 equals the limit as h goes to 0 of f of negative 1 plus h minus f of negative 1, all of this divided by h. Next thing to do is to evaluate the function at negative 1 plus h and negative 1. F of negative 1 plus h means to take f of x and replace each x with a negative 1 plus h, so we will have the square root of negative 1 plus h squared minus 3 times a negative 1 plus h. And we're going to subtract from that f of negative 1, which is going to be the square root of replacing all the x's with a negative 1, negative 1 squared minus 3 times a negative 1. All this is over h. Now we have the 0 over 0 indeterminate form, and we're going to continue to have that until we can factor an h out of the numerator to cancel with that h in the denominator. That's always our goal. So f prime of negative 1 equals limit as h goes to 0 of the square root. Negative 1 plus h can be written as h minus 1. It might be a little nicer looking to write it that way. And I'm going to write it that way with the negative 3 as well. I'm not going to expand anything in that root just yet. I will expand the other root though. And that will give us a negative 1 squared, which is a positive 1, and then a negative 3 times a negative 1 is a positive 3 all over h. So we have limit as h goes to 0 of the square root of h minus 1 squared minus 3 times h minus 1, and then minus the square root of 4, which I'll actually evaluate that to be a 2. I haven't expanded the other root at all, and the reason for that is we have a 0 over 0 indeterminate form here due to a root involving the variable h in some way, added or subtracted with at least one other term, which means we're going to have to make use of a root conjugate. So it's best just to keep that from being expanded just yet, because it'll probably be messier looking once we do expand it. We will have to expand it later, but I will wait till after we have taken care of the root conjugate. Square root of 4 is a 2, so we have a minus 2 over h. And since we have that root combination, we can now multiply the numerator and denominator by the root conjugate. It will be h minus 1 squared minus 3 times h minus 1 under the square root. None of that changes, but then opposite sign, so plus 2. And we're going to put this over itself. So that we have a form of 1, so that when we multiply we don't change the value, just the look. The numerator is a root conjugate pair. We're going to FOIL that out. First, root times root will give us h minus 1 squared minus 3 times h minus 1. The outside is going to be a positive 2 times that root. and the inside is going to be a negative 2 times that same root. Those, of course, will cancel, as they always do when you FOIL out a root conjugate pair. The outside and inside terms cancel, and then last is negative 2 times a positive 2, which is a negative 4. The outside and inside terms will cancel each other out. In the denominator, we're not going to distribute or FOIL. We will just leave it factored, but it will be h times this entire quantity that would have been the root conjugate from the numerator. At this point, we're going to want to expand, because our goal is still the same. We need to factor an h out of the numerator to cancel with the h in the denominator, so we need to expand the remaining expressions in the numerator. H minus 1 squared will be h minus 1 times h minus 1. I'm going to distribute the negative 3, which will give us a negative 3h plus 3. And then don't forget we have that negative 4 at the end. Let's not forget about that one. All over h times the quantity of the root of h minus 1 squared minus 3 times h minus 1, and all of that added to 2. FOILing out h minus 1 times h minus 1, first h squared, outside negative h, inside negative h, and last positive 1. And then we also have a minus 3h, a plus 3, and a minus 4 all over that denominator. Which we won't change. We're going to combine together like terms now in the numerator. And the terms that do not have an h in them, which should just be constants, should fully cancel. I have a positive 1, a positive 3, and a negative 4, and those do fully cancel out. So we have limit as h goes to 0 of, we're left with an h squared. We have 3 terms that are h, and a negative 3h. Those will combine to be a negative 5h. All of this divided by that entire denominator. Which we just keep rewriting. We now have an h that can factor out of the numerator, and that will cancel with the h in the denominator. So it'll be h times h minus 5. And the denominator will leave the way it is. And these h's can cancel. At this point, we should no longer have the 0 over 0 indeterminate form, and we can plug a 0 in for the remaining h's. In the numerator, that will give us a negative 5. In the denominator, that will give us the square root of what will be h minus 1. 0 minus 1 will be negative 1 squared, minus 3 times h minus 1. 0 minus 1 will be negative 1. All that's under the square root, and then add that to a 2. So we have negative 5 over the square root of negative 1 squared, which is 1, minus 3 times negative 1 is 3. 1 plus 3 is 4. So square root of 4 plus 2. And square root of 4 is a 2, so we get a negative 5 divided by 4. that will represent f prime of -1, or the derivative of f of x evaluated at -1.